This is a key to worksheet 2.6 part 3, and on this worksheet you're going to have two functions and you're going to combine those functions, whether it's addition, subtraction, multiplication, or division. All right. And so in number 1 you have these two linear functions, and so you want to add those two functions. Now this notation, you have to know your notation. So by definition, g plus f at x means g of x plus f of x. All right, and so in the previous lesson or in the previous worksheet, you were asked to evaluate these functions at a numerical value. And so notice that when you did that, you got numerical answers. In this particular case, you're evaluating it at the variable x. And so basically all you do is just, in this case, you find out what g of x is. You know what it is. It's x plus 5. So g of x equals, you think of equals right here, equals x plus 5. But you're adding it to this function f of x, which equals 4x minus 3. And so basically g of x plus f of x, or g plus f at x, will equal these two functions added together. So you just combine like terms. So 4x plus x is 5x. 5 minus 3 is positive 2. So you get 5x plus 2. All right, in part B, you're asked to subtract those two functions. And so by definition, g minus f at x means g of x minus f of x. So g is listed first, you put it first. See, this is subtraction. Subtraction, the order in which you put it matters. So because remember, the only operation that's commutative is addition and multiplication. So subtraction is not commutative. The order in which you subtract does matter. So you're going to notice in a little while I'm going to have to put some stuff in parentheses. All right, so g of x, we know what that is. That's equal to the expression x plus 5. But I'm subtracting f of x. See here, I didn't put that in parentheses because it wasn't needed. It was not needed that I put the function f of x in parentheses or g of x in parentheses. It wasn't needed, but here it is needed because I'm subtracting every term that is f of x. So f of x is 4x minus 3, so that is needed. And then you get rid of the parentheses so you can distribute, and so I get x plus 5 minus 4x plus 3. And so therefore f, which equals x, combining like terms, x minus 4x is negative 3x, and then 5 plus 3 is 8. So therefore g minus f at x then is equal to this function, negative 3x plus 8. Okay, then in C you're multiplying, so by definition that is f of x times g of x. All right, now again, don't confuse that multiplication with composition. So remember, composition is that open circle. All right, so then we have f of x, which is 4x minus 3. Now you see how 4x minus 3. You see how I'm multiplying? So you need that in parentheses because what's happening is you're multiplying these two binomials. So you have to know when to put in parentheses, when not to put in parentheses. And then all you do is use the FOIL method here, since those are two binomials. So I get 4x times x is 4x squared. The outer is 20x. The inner is a negative 3x. And the last is a negative 15. And then combining like terms, I get 4x squared plus 17x minus 15. And so that is the product of f and g, of the functions f and g. So that's 4x squared plus 17x minus 15. All right, in letter D, you're dividing those two functions. Now notice that, remember, the only operations that are commutative are addition and multiplication. So subtraction and division are not commutative. The order in which you subtract and the order in which you divide does matter. So since g is in the numerator, you have to put g in the numerator. So by definition, this notation means g of x divided by f of x. And so then g of x, you know, is x plus 5. And then f of x, you know, is 4x minus 3. So you have this rational expression, this rational function. So notice that all of these three are polynomial functions now. So when you add those two, when you add, see how these are polynomial functions? We learned that in a previous lesson. So when you add polynomial functions, you get a polynomial function. When you add polynomial functions, when you subtract polynomial functions, you get a polynomial function. When you multiply polynomial functions, you get a polynomial function. But you're dividing polynomial functions, so you end up with a rational function. All right, so that's rational. Now, just as in a previous lesson, previous courses, you want to factor this and then reduce. Well, you can't factor x plus 5, and you can't factor 4x plus 3, so there's nothing to reduce. So then the answer is just this. It's x plus 5 divided by 4x minus 3. But it's important that you remember what I just said. You're adding polynomial functions, you get a polynomial function. You're subtracting polynomial functions, you get a polynomial function. Multiply, polynomial function. You're dividing, you get a rational function. All right, now, remember in a previous lesson, you were asked to determine the domain of this rational function. They're not asking this here, but just remember you did that before. Okay, now in this case, you want, again, you're dividing, except this time f of x is going to be in the numerator. So that's going to be f of x divided by g of x. And so f of x is, remember, 4x minus 3, and then g of x is x plus 5. And again, if you can, you factor and reduce. All right, so notice that I get this I get this rational function. So 4x minus 3 divided by x plus 5. All right, so that was the first page. The second page, the only difference between the second page is that on problem 1, those were two linear functions. In problem 2, your function f of x is linear. That's a linear function. But this is not linear. This is quadratic. Okay? All right. So the same idea is going to apply. You're going to do the same thing you did in problem 1. All right, number 1, by definition, this means f of x plus g of x, right? And so don't forget, it says show work, so you have to show work. So f of x is 3x plus 1. I don't need parentheses since I'm adding. And then g of x is this quadratic function, so that's 3x squared minus 11x plus 4. So notice I'm adding two polynomial functions. I'm going to get a polynomial function. So when I combine like terms, that's going to, and let's put in descending order. So that's 3x squared. 3x and negative 11x is a negative, 8x. And then 1 and 4 is 5. So so those two functions add together gives me this new function, which is 3x squared minus 8x plus 5. All right, so basically just remember also, and I need to mention this again, we talked about this in a previous lesson, but when see how these functions are totally different, you're adding them, you get a different function as well. All right, so when you add functions, you get a different function. All right, so this function, this function, this function are three different functions. Okay. All right, so when I add those two functions, I get a new function, which is this function. All right, so in this one, by definition, remember that your subtraction, so the order matters. So g of x minus f of x. By definition, that's what that notation equals. G of x is this quadratic, so 3x squared minus 11x plus 4 minus f of x. Now remember your subtractions, you got to put that in parentheses because you're subtracting all of these terms, 3x plus 1. Then get rid of the parentheses, distribute the negative. I get 3x squared minus 11x plus 4 minus 3x minus 1. And so you get 3x squared. A negative 11x and a negative 3x is negative 14x. And then 4 and a negative 1 is a positive 3. So there's your new function. So 3x squared minus 14x plus 3. Now, what is the difference between these two, b and c? So in b, you have g minus f, right? You're still dealing with those two functions. And then f minus g is part c. So notice that those are opposites. So g minus f and f minus g would be opposites, right? Okay, so if you didn't remember that, just remember this right here. I'm going to go ahead and do that right here. So y'all agree that that if I have 7 minus 6 and then 6 minus 7, then those are opposites, right? 7 minus 6 is 1, 6 minus 7 is negative 1. So those are opposites. Okay, 1 and negative 1 are opposites. So these are opposites. So if you found this one right here, now you still have to show the work, but I'm just saying this. If you found g minus f, and you're still doing the same function g and f, then what would f minus g be? It would be the opposite of this. So in other words, you would say that's negative 3x squared. What's the opposite of negative 14x? Positive 14x. And what's the opposite of positive 3? Negative 3. But it still says show work. So you have to show your work. So you got to do the same way you did this. But that's what you would get. All right, so by definition, this means f of x minus g of x, right? F of x is 3x plus 1. You're subtracting g of x. You got to put that in parentheses. So g of x is 3x squared minus 11x plus 4. Get rid of the parentheses. I get 3x. All these are equal to each other. I get 3x plus 1 minus 3x squared. A negative times a negative is a positive, right? So plus 11x and then minus 4. Combine like terms. Let's put in descending order. I get negative 3x squared. 3x and 11x is 14x. And then positive 1, negative 4 is a negative 3, and that's what you got here. Okay? All right, now over here, you're multiplying. So by definition, that is f of x times g of x, right? Okay, now I'm going to probably need more room, so I'm going to do this on another page. So let's do that here. So it'll be d. And the reason I'm going to need more room here, see how over here I really didn't need any extra room because I was multiplying two binomials and I used the FOIL method. Over here, what do you notice is happening though? So this is f of x times g of x. Well, f of x is a binomial, right? Again, you multiply, so you got to put that in parentheses. But g of x is not a binomial, so you can't use the FOIL method. You're going to have to use the distributive property. So I get this for g of x. So remember how we did this. So you take each term in the first polynomial, and you're going to multiply by the second polynomial. So basically this means that 3x is going to be multiplied by the second polynomial. So that's the distributive property. So this times this times this. So 3x squared minus 11x plus 4, and then plus 1 times the second polynomial. So 3x squared minus 11x plus 4. And then we use the distributive property again. And so when I do that, I get 3x times 3x squared is 9x cubed. 3x times the negative 11x is a negative 33x squared. And 3x times 4 is 12x. And remember, 1 times, if this is the coefficient 1 and you're multiplying it by this quadratic expression, then it's just a quadratic expression. So 1 times all of these is that polynomial. So that's just 3x squared minus 11x plus 4. Then combine like terms. Let's put in descending order. So I get 9x cubed, negative 33x squared, and a positive 3x squared is a negative 30x squared. 12x and a negative 11x is just 1x, and then your constant is just 4. All right, so that is the product. So that's going to go here. All right, so just see other page. All right, so that's going to be 9x cubed minus 30x squared plus x plus 4. Okay? All right, and over here you want to divide. Now remember all of these, adding polynomial functions, subtracting, multiplying gives you a polynomial function. Right? So dividing gives you a rational function. Now let's look at this. So by definition, this is f of x divided by g of x. And so f of x is 3x plus 1. And g of x is 3x squared minus 11x plus 4, right? Okay. Now, remember in part E, you need to factor and D and E, since you had those, you had to check and see if you could factor and reduce, if possible. And I couldn't here. All right. But here I probably could. So let's and obviously you can't because I'm telling you to factor and reduce. So the numerator, that's linear, and the GCF is 1, so I can't do anything with the numerator. And the denominator, since that's quadratic, the GCF is 1. Let's go to two binomials. So let's try 3x and x, and let's try 4 and 1, and negative, positive. So let's check this. So 3x times x is 3x squared. Positive 1 times a negative 4 is a negative, oops, sorry. That should be, all right, so I kind of did that wrong, didn't I? Let's see, I think I may have messed up with the expression. Okay, so obviously I can't factor this. So that's not true because a positive 1 times negative 4 is a negative 4, and I wanted a positive 4. So that can't factor like that. And even if you did this, 3x, x, 2, 2, see, that wouldn't work either. So I can't factor this. So that's your answer right here. But I do want to say this, though. What I meant, and I did not, let me go ahead and finish this. All right, so basically, I did want this to factor, and it did. So factor reduce, and it did not. What I probably should see with this right here, the plus 4, that should be the minus 4. So let's look at this. Suppose it was this. Let's make this an E. All right, an E. So let's suppose, well, let's make this 3. Suppose that f of x is 3x plus 1, and g of x is 3x squared minus 11x minus 4. Okay? All right. Now, let's suppose I want to find E. Suppose I want to find f of x divided by g of x. All right, f of x is 3x plus 1, right? And then g of x is this, 3x squared minus 11x minus 4. All right, if I factor, I get 3x plus 1 divided by, and then now this becomes 3x, x, 4, 1, minus plus. Okay, so that's what I really wanted, and I kind of messed that up, so I would have to change it for another situation. All right, now if I reduce, these divide out. Remember, the common factors. You have one in their factor, one in their place, so you get 1 divided by x minus 4. Okay. All right, so that was if it should have been that negative 4 instead of a positive 4. But anyway, so here you really can't factor and reduce. Okay. All right, so that is the key to section 2.6, part 3.